Lee Min-ho pressed his face against the thick glass window of his dormitory room and watched the artificial sky above. Kepler Station Academy turned dark gray. The massive dome that covered the residential section was showing storm clouds that looked so real he could almost smell the rain. But these weren't just pictures or holograms. The weather simulation system could create actual storms with real wind, rain, and lightning. Another storm drill, Min-ho said to himself in Korean, then switched to Galactic Standard. I hope this one doesn't last too long. His roommate Vextai turned toward him. The crystalline being's body caught the dim light from outside and through. Rainbow patterns across the walls. When Vextai spoke, his voice sounded like wind chimes. These exercises are important for emergency preparation. My species has detailed protocols for severe weather events. Thum, who looked like a cloud of purple gas floating near the ceiling, made a sound like distant thunder. The nebulae people have studied atmospheric disturbances for thousands of years. We understand storm patterns better than most species. Chixara lifted her blue-green head from the water tank that served as her bed. The aquatic being's gills fluttered as she spoke. Water systems on hydrozoan worlds can handle much worse storms than this simulation. Min-ho nodded politely. His 3 alien roommates were all very smart and came from advanced civilizations. Sometimes he felt like the only primitive one in their group. Earth was still new to the galactic community, and human technology seemed simple compared to what other species had built over millions of years. Thunder rumbled overhead, and the first drops of rain began hitting their window. Min-ho had lived through many real storms back on Earth. His family's house in Bizan had survived several typhoons, and he remembered helping his father put sandbags around their home when the flooding got bad. The rain is starting, Min-ho observed. Vextai's crystal body began to glow brighter. My internal sensors indicate this will be a Category 3 simulation. Standard protocol should handle it easily. But something felt different about this storm. Min-ho couldn't explain it, but the wind sounded wrong. Too wild, too angry. Real storms had a certain energy to them that simulations usually missed. The lights in their room flickered once, then twice. Thum's gaseous form shimmered with concern. That should not happen during a drill. Through their door they could hear other students moving around in the hallway. Voices in different alien languages mixed together, creating a sound like a strange orchestra. Some voices sounded worried. Rain began hitting their window harder. Each drop sounded like a small rock. Min-ho watched the water run down the glass in twisted streams. The artificial storm was getting stronger than any drill he had seen before. Maybe we should check what's happening outside, Min-ho suggested. Chixara swam to the edge of her tank. The atmospheric pressure feels unstable. This does not match normal simulation parameters. A loud crash echoed through the building, followed by the sound of rushing water. Emergency lights began flashing in the hallways. The 4 roommates looked at each other with growing concern. Vextai's body started making high-pitched ringing sounds, which meant he was accessing the station's information network. After a few seconds, his glow dimmed. I cannot connect to the main systems. The network appears to be experiencing disruptions. More sounds came from outside their room, footsteps running, doors slamming, someone shouting in what sounded like panic. The emergency lights kept flashing, casting red shadows on their walls. Min-ho opened their door and looked into the hallway. Students from different species were standing outside their rooms, looking confused and frightened. The tall, insect-like arachnoids were clicking their mandibles nervously. A group of rock-like lithoids were huddled together, their bodies glowing. With stress patterns, Kang Jiwoo, one of the hydrozoan resident advisors, was swimming quickly through a water-filled tube that ran along the ceiling. She was trying to communicate with different student groups, but her voice sounded strained. All students should remain in their rooms, Kang Jiwoo announced. We are experiencing technical difficulties with the weather simulation system. But even as she spoke, water began seeping under some of the doors further down the hallway. Not the small amount that might come from a minor leak. but steady streams that suggested something much worse. Park Seung-hoon, a senior silicaride student, was trying to create crystal barriers to block the water. His species could grow and shape crystalline structures at will, but the barriers he made kept cracking under some unseen pressure. "The water flow is too strong," Park Seung-hoon said, his voice showing strain. "This is not normal simulation levels." Minho stepped further into the hallway. The sound of rushing water was getting louder, coming from the direction of the main stairwell. Other students were starting to look really scared now. Many of them had never experienced actual emergencies before. Their homeworlds had technology that prevented most natural disasters. Thum drifted out of their room, his gaseous form becoming more dense with worry. "The atmospheric moisture levels are increasing beyond safe parameters for my species." A new sound joined the chaos, the sharp crack of breaking glass. Somewhere in the building, the storm had found a weak point. Real wind began howling through the hallways, bringing with it the smell of actual rain and ozone. Vex single quotes Tai emerged from their room, his crystal body now pulsing with alarm patterns. "The simulation dome has been compromised. This is no longer a drill." The realization hit all the students at the same time. The weather simulation system hadn't just malfunctioned, it had completely failed. The artificial storm had become a real one, and now actual rain, wind, and flooding were pouring into their residential section. Chixara had left her tank and was now in a portable water suit that let her move around on land. "We need to evacuate to higher levels immediately." But when several students tried to access the main stairwells, they found water already flooding the lower floors. The elevators had stopped working when the power systems became unstable. Emergency! Exits were blocked by debris from broken dome sections. Panic began spreading through the group of students. Many species had never dealt with unpredictable natural disasters. Their civilizations had learned to control their environments so completely that they had no experience with chaos and emergency improvisation. Minho watched his fellow students struggle with a situation that had no clear technological solution. Kang Jiwoo was still trying to coordinate evacuation, but her communication with the main emergency systems kept cutting out. Park Seung-hoon's crystal barriers were failing faster than he could rebuild them. The water in the hallway was now ankle-deep and rising steadily. It carried with it pieces of debris, broken electronics, and a sharp smell of ozone from damaged electrical systems. The emergency lighting was starting to fail in some sections, leaving pools of darkness between the red flashing lights. Minho felt something familiar in all this chaos. Not comfort exactly, but recognition. This was like the typhoons back home in Bizen, the uncertainty, the rising water, the need to think quickly with whatever materials were available. His family had survived these situations not through advanced technology, but through simple preparation and creative problem-solving. As he watched his alien classmates struggle with their failing high-tech solutions, Minho began to notice patterns in how the water was flowing through the building. Where it pooled, where it moved fastest, how it interacted with the building's structure. His human eyes, trained by evolution to recognize environmental patterns, started seeing possibilities that the others were missing. The storm outside was getting worse and more water was pouring in every minute. But for the first time since arriving at the academy, Minho felt like there might be something uniquely human he could contribute to solving this problem. The water level in the hallway had risen to knee-deep within just 20 minutes. Minho watched as his alien classmates became more desperate in their attempts to escape or control the flooding. The situation was getting worse by the minute, and their advanced technologies were proving useless against the chaotic forces of nature. Vextai was having the worst time of all. The crystalline being's body required precise temperature and humidity conditions to maintain structural integrity. As the water level rose and the air became more humid, stress fractures began appearing across his translucent skin. Each crack made a sound like breaking glass, and his usual rainbow glow was becoming dim and flickering. "My molecular structure is becoming unstable," Vextai said, his wind chime voice now harsh and discordant. "I cannot maintain cohesion in these atmospheric conditions much longer." Thume was facing different but equally serious problems. The gas-being species needed specific atmospheric pressure to keep their form intact. The storm had changed the air pressure throughout the building, and Thume's purple, cloud-like body was starting to spread out and lose definition. Parts of his consciousness were beginning to drift away with the air currents created by the rushing. "Water, I am losing density," Thume said, his voice becoming fainter as his form dispersed. "Cannot maintain communication much longer." Even Chixara, who was naturally comfortable in water, was struggling. The flooding carried dangerous electrical currents from damaged power systems throughout the building. Every few minutes, sparks would flash through the water, and she would have to retreat to avoid being shocked. Her portable water suit also wasn't designed for extended use outside her tank. "The water is electrically charged," Chixara warned. "The others? I cannot safely guide anyone through the flooded areas." More students were gathering in the hallway now, driven from their rooms by rising water levels. Bei Taeyang and Choi Yuna, two other human students, had made their way upstairs from the lower floors. They were both soaking wet and looked exhausted from fighting their way through the flooding. "The first 3 floors are completely underwater," Taeyang reported. "The emergency stairwells are blocked and the water is rising fast." Yuna, who was studying medicine at the academy, was checking on students who had been injured during the evacuation. Several lithoids had cracked their rock-like shells when debris hit them. A group of small, bird-like avians were huddled together, their feathers waterlogged and unable to fly. "We need to get everyone to higher ground," Yuna said. "But the main evacuation routes are all blocked." Kang Yu was still trying to coordinate the evacuation, but she was swimming frantically between different groups of students. Her usual calm demeanor was gone, replaced by visible panic. The hydrozoan species were used to being in control of water situations, but this chaotic flooding was beyond anything in their protocols. "Emergency services are not responding," Kang Ji-woo announced. "The main communication array appears to be damaged. We are on our own until the storm passes." Park Seung-hoon was still attempting to create crystal barriers, but each one he built would crack and fail within minutes. The water pressure was too strong and too unpredictable for his species' usual architectural solutions. Sweat was forming on his rock-like skin as he pushed his abilities to their limits. "The water flow patterns are completely chaotic," Park Seung-hoon said between attempts to build new barriers. "My calculations cannot predict where to place structural supports." A group of arachnoid students had tried to use their natural web spinning abilities to create barriers, but the rushing water simply tore through their silk strands. The tall, spider-like beings were also having trouble moving through the flooded areas because their long legs kept getting tangled in floating debris. Kim Dong-yoon, another human student who was studying physics, tried to help by explaining the water flow to some of the alien students using mathematical concepts they understood. But even with his scientific knowledge, he couldn't suggest any practical solutions. "The fluid dynamics are following expected patterns," Dong-yoon explained to a group of confused nebulae students. "But the volume and pressure exceed the building's design parameters." The alien students listened to his explanation but seemed even more frustrated afterward. They were used to problems that could be solved with precise calculations and advanced technology. This situation required something different, the ability to work with unpredictable forces using whatever materials were available. Lim Soyoung, a human linguistics student, was helping translate between different species groups. Many of the aliens were reverting to their native languages under stress, making communication even more difficult. She was running back and forth between groups, trying to keep everyone informed about what was happening. "The lithoids are saying their emergency protocols don't cover water-based disasters," Soyeon translated. "The avians are asking if anyone can fly them to safety, but the air currents are too dangerous." More concerning sounds were coming from other parts of the building. They could hear glass breaking, metal groaning under pressure, and the constant roar of water rushing through spaces where it didn't belong. The storm outside showed no signs of stopping, and if anything seemed to be getting stronger, Minho moved through the chaotic hallway, observing how each species was trying to deal with the crisis. The silicarites were attempting to build their way out of the problem. The nebulae were trying to calculate their way out. The hydrozoans were trying to swim their way out. The arachnoids were trying to web their way out, but none of their species specific. Solutions were working because this wasn't a problem that could be solved by any single advanced ability. It was a messy, unpredictable situation that required adaptation and improvisation. Minho remembered the floods back home in Bizan. When the typhoons came, his family didn't try to stop the water or calculate its flow patterns. They worked with it, they redirected it. They used simple materials to guide it where they wanted it to go. Instead of trying to fight against its natural movement, the water in the hallway was flowing in patterns that reminded him of the streams behind his childhood. Home during heavy rains. It found the easiest path, followed gravity, and could be influenced by placing obstacles in the right positions. The alien students were trying to stop the water completely, but maybe the solution was to guide it instead. Minho started looking around the hallway with new eyes. The abandoned rooms, the furniture, the bedding, and personal belongings that students had left behind as they evacuated. Materials that the aliens saw as useless debris, but that human experience suggested might be exactly what was needed. Yuna, Taeyang, Minho called to his fellow humans. I think I have an idea. The two other humans looked at him with hope. Around them, the alien students continued their increasingly desperate attempts to solve the flooding with methods that weren't working. The water kept rising and time was running out. While the alien students continued trying to solve the flooding with their advanced technologies, Minho began moving through the hallway with a different purpose. Instead of looking for technological solutions, he started gathering simple materials that others had abandoned in their rush to evacuate. Minho, what are you doing? Yuna asked as she watched him pull heavy blankets from an empty room. Back home in Bizenmez, when the typhoons flooded our neighborhood, we didn't try to stop the water, Minho explained while dragging a thick comforter into the hallway. We redirected it, guided it where we wanted it to go. Taeyang looked skeptical. With blankets? With whatever we had, Minho replied. Sandbags, tarps, furniture, anything heavy enough to change the water's path. The alien students noticed Minho's activity, but didn't understand what he was trying to accomplish. Vextai, despite his increasing structural problems, managed to ask, how can textile materials address hydraulic engineering challenges? Minho didn't answer immediately. Instead, he was studying the water flow patterns in the hallway. The flooding wasn't completely random. It followed the building's layout, flowing fastest where the floor sloped downward and pooling in areas where furniture or debris created obstacles. Look at how the water moves, Minho said to Yuna and Taeyang. It's not just spreading everywhere equally. It's following specific paths. Yuna began to see what he meant. The water was flowing fastest along the main corridor, where the floor had a slight downward slope toward the central stairwell. It moved more slowly in the side areas where room furniture created partial barriers. If we could block some of these? Fast-moving streams, Yuna said, understanding dawning in her voice. We could force the water to go where the building's drainage systems might still be working. Taeyang joined them in collecting materials. But blankets won't hold against water pressure. Not by themselves, Minho agreed. But weighted down with furniture made into proper barriers placed in the right spots. He gestured toward a side corridor where the water was moving more slowly. We don't have to stop all the water, just redirect the worst of it. The three humans began working together, pulling heavy blankets, comforters, and even mattresses from evacuated rooms. They also gathered furniture, chairs, desks, anything dense enough to serve as anchor points. Choi Yuna proved particularly helpful because her medical training had taught her to think systematically under pressure. She began mapping out the hallway's layout, identifying the main flow channels and the areas where their improvised barriers might be most effective. If we can redirect the main flow away from the residential areas toward the central drain systems, Yuna said, sketching with her finger on a wet wall. We might be able to lower the water level enough for people to evacuate safely, the alien. Students watched this activity with growing confusion. Park Seung-hoon approached them, his crystal body showing stress fractures from the humid conditions. Your methodology appears to lack scientific precision, Park Seung-hoon observed. How? Can you calculate proper barrier placement without detailed hydraulic modeling? Minho looked up from where he was positioning a heavy desk. We're not calculating, we're observing and adjusting. This concept seemed to puzzle the Silicroid student even more. His species solved problems through careful analysis and precise engineering. The idea of working without detailed calculations was foreign to him. Thum, whose gaseous form was now noticeably dispersed, managed to communicate through the building's air circulation system. Human approach ... seems ... inefficient ... why not? Use proper ... flood control ... technology? Because we don't have proper flood control technology, Tae-young replied practically. We only have what's here in the building. This simple statement highlighted the fundamental difference between human and alien approaches to problem solving. The aliens kept looking for the right technology to solve the problem. The humans were working with whatever materials were available. Kim Dong-yoon arrived with more supplies, having understood what his fellow humans were attempting. I found some rope in the maintenance closets, he announced. And there are more heavy blankets in the storage rooms. As the humans continued their work, some of the alien students began to show curiosity about their methods. Chixara, swimming carefully to avoid electrical currents, came closer to observe. Your species appears to be improvising solutions without proper planning phases, Chixara noted. This violates standard emergency protocols. Sometimes you don't have time for proper planning phases, Yuna replied while helping Minho position. A blanket barrier. Sometimes you have to work with what's available and adapt as you go. Lin Soyoung joined the group, bringing her linguistic skills to help coordinate their efforts. I've been talking to students from other floors, she reported. The same flooding problems are happening throughout the building. The alien students are all trying different technological solutions, but none of them are working. More humans began arriving as word spread about their unconventional approach. Hanyul, a senior human student, appeared with additional supplies and helpers. Cheon Woojin and Song Minji, both first-year students, volunteered to help gather materials. This is like the flood response training we had back on Earth, Hanyul observed. Work with the disaster instead of against it. The growing group of humans began to work with increasing coordination. They developed a system where some gathered materials, others studied water flow patterns, and still others positioned and adjusted the improvised barriers. Minho found himself naturally taking a leadership role, not because he had appointed himself, but because his understanding of flood dynamics from Earth experience made him effective at directing their efforts. He could see where the water wanted to go and how their barriers could guide it there. Woojin, put that chair about 2 meters further toward the wall, Minho directed. Minji, we need another heavy blanket to extend that barrier toward the drainage. Point. The alien students continued to watch with fascination and growing respect. They had never seen problems solved through such intuitive, adaptive methods. Their civilizations had become so advanced that they had forgotten the value of working with simple materials and basic observation. Vextai, despite his deteriorating condition, made an effort to understand their approach. You are not attempting to control the water's behavior, you are cooperating with its natural movement patterns? Exactly, Minho confirmed. Water always wants to flow downhill and find the easiest path. We're just giving it a better path to follow. As their improvised barrier system began to take shape, the first signs of success started to appear. Water that had been pooling in the residential areas began flowing more toward the central drainage systems. The flooding wasn't stopped, but it was becoming more manageable. The alien students watched in amazement as simple materials and human adaptability began to accomplish what their advanced technologies had failed to achieve. Minho stood waist-deep in the rushing water, holding one end of a heavy blanket while Yuna secured the other end around a desk leg. The improvised barrier was working better than he had expected. Water that had been flowing directly into the residential corridor was now being redirected toward a maintenance area, where the building's drainage systems were still partially functional. "It's working," Yuna called out over the sound of rushing water. "The water level in the residential area has dropped by almost 10 centimeters. Taeyong was positioned further down the hallway, adjusting another blanket barrier that was channeling water away from the lithoid students' rooms. Their rock-like bodies couldn't handle prolonged exposure to water, and the flooding had been putting them in serious danger. "The flow rate here has decreased significantly," Taeyong reported. "The main stream is following our redirect path." Kim Dong-yoon approached Vextai, who was struggling to maintain his crystalline structure in the humid conditions. "The physics." Student began explaining the principles behind their improvised dam system using mathematical concepts that the silicarite could understand. "The humans are applying fluid dynamics principles through empirical observation rather than calculation," Dong-yoon explained. "They identify pressure points and flow vectors, then use weighted barriers to alter the water's preferred path." Vextai's crystal body flickered with interest despite his deteriorating condition. "This is environmental manipulation through material physics rather than technological control?" "Exactly. They're working with the water's natural behavior instead of trying to override it." This explanation seemed to resonate with Vextai's scientific understanding. He began to see the elegance in the human approach, even though it was completely different from silicarite engineering methods. Lin Soyang was helping translate the human strategy to other alien students. Many species had never encountered this type of problem-solving before, and their languages didn't even have words for concepts like improvisation or working with natural forces. "The humans are not fighting the water," Soyoung explained to a group of confused nebulae students. "They are convincing it to go where they want it to go." The nebulae, being gas-based life forms, actually understood this concept better than most other species. They were used to flowing with atmospheric currents rather than trying to control them completely. Several nebulae students began expressing interest in helping with the human approach. Haniel arrived with reinforcements, more human students, who had heard about their flood control efforts. Chung Woojin and Song Minji brought additional supplies, including more rope and some plastic sheeting they had found in a maintenance storage area. "We've tested the barriers on the lower floors," Haniel reported. "The same principles work there too. We're seeing water level reductions of 15 to 20 centimeters in the areas where we've installed the redirect systems." Minho felt a surge of satisfaction as their improvised engineering project began showing real results. But more importantly, he noticed that some of the alien students were starting to contribute to their efforts instead of just watching. Vextai, despite his structural problems, began using his crystalline abilities to create anchor points for their blanket barriers. His crystal formations weren't designed to stop water, but they could provide solid attachment points that were stronger than furniture legs. "I can create molecular-level bonding points," Vextai offered. "These will hold your textile barriers more securely than mechanical fasteners." Thum, whose gaseous form had been dispersing in the chaotic air currents, discovered that he could help by testing air pressure differentials around their barriers. His species' natural ability to sense atmospheric conditions proved useful for optimizing the redirect system. "Pressure variance ... indicates ... improved flow patterns," Thum communicated through the building's ventilation system. "Human barriers ... creating ... beneficial ... air displacement." Even Chixara found ways to contribute. Although she couldn't safely guide people through the electrically charged water, she could observe the underwater flow patterns and report back about areas where their barriers needed adjustment. "The underwater currents show the main flow is now following your redirect channels," Chixara reported. "But there's still turbulence near the intersection of corridors 7 and 8. Minho appreciated how the aliens were beginning to work as part of his team rather than pursuing their own separate solutions. Their advanced abilities were valuable, but only when applied as components of the overall human strategy. Nam Ji-hoon, the head of engineering for the entire station, arrived with the emergency response team just as their improvised dam system was showing its greatest success. The tall, spider-like arachnoid stood in the hallway, looking around at the blanket barriers and furniture redirects with obvious amazement. "What is this methodology?" Nam Ji-hoon asked, his mandibles clicking with curiosity. "Our advanced flood? Control systems have failed, but these textile installations appear to be effective." Song Minji, who was helping maintain one of the central barriers, explained their approach. "We're not trying to stop the flooding. We're guiding it toward areas where the building's drainage can handle it." Professor Krickstel, a renowned nebulae physicist who had arrived with the emergency team, began studying their barrier system with scientific fascination. The gas being's form shimmered with excitement as he observed the elegant simplicity of their solution. "Remarkable, Professor," Krickstel commented. "Your species has developed intuitive understanding of fluid dynamics without requiring computational analysis. This is unprecedented in galactic engineering practices." The emergency team included advanced equipment designed to handle flood situations, but much of it was useless because the station's power grid was still unstable. The humans' low-tech approach was proving more reliable than systems that depended on complex technology. "Our pumping systems cannot function without stable power connections," Nam Ji-hoon admitted. "And our structural modifications require precise calculation periods that we do not have in this emergency." Minho watched as more alien students began joining their efforts. The arachnoids discovered that their web-spinning abilities could reinforce the blanket barriers, making them stronger and more flexible. The lithoids found that their natural weight could serve as excellent anchors for redirect points. "Your approach appears to be adaptive," observed Park Seung-hoon, who had abandoned his attempts to build crystal barriers and was now helping position furniture anchors. "You modify the system based on observed results rather than predetermined calculations." "That's how humans solve problems," Yuna explained while adjusting a redirect barrier. "We try something, see what happens, then make it better." This concept of iterative improvement was foreign to most alien engineering philosophies. Their species typically solved problems through detailed analysis followed by precise implementation. The idea of building solutions through trial and adjustment was revolutionary to them. As the improvised dam system expanded throughout the residential section, the flooding became increasingly manageable. Water levels continued to drop in critical areas, and evacuation routes that had been impassable were becoming accessible again. The alien students, who had been trapped by the flooding, began expressing amazement at the effectiveness of the simple human approach. Their advanced civilizations had never developed this type of adaptive problem-solving, because they had never needed to work with such limited resources. Humans demonstrate environmental manipulation capabilities that our databases did not predict. Vextai observed his crystal structure, stabilizing as the humidity levels dropped in their area. Minho smiled as he watched aliens and humans working together to expand their improvised flood control system. For the first time since arriving at the academy, he felt like humanity had something unique and valuable to contribute to the galactic community. As word spread throughout the residential section about the humans' successful flood control system, more alien students began abandoning their own failing solutions to join the Blanket Barrier Project. What had started as a small group of humans working with simple materials was rapidly becoming a multi-species collaboration. Vextai was the first to fully commit to the human approach. His crystalline body had stabilized as the humidity levels dropped in their section, and he began using his molecular manipulation abilities to create perfect anchor points for the expanding barrier system. "I can form crystal lattice that bond directly with your textile materials," Vextai explained as he created a shimmering anchor point that held one of their heaviest blanket barriers in place. "This provides structural integrity without requiring the water resistance that my previous barriers needed." Minho appreciated how Vextai had adapted his natural abilities to support the human strategy rather than trying to replace it. The crystalline being was learning to work as part of a team instead of relying only on his species. Advanced engineering methods. Thuum had also found ways to contribute his gaseous abilities to their project. By dispersing parts of his consciousness through the building's air circulation system, he could monitor atmospheric pressure changes throughout the residential section and report back about areas where their barriers were most effective. Pressure readings indicate optimal flow redirection. In sections 12 through 15, Thuum communicated through the ventilation system. Turbulence patterns suggest barrier adjustments needed. In section 9, Chixara proved invaluable for underwater reconnaissance. She could safely navigate the flooded areas and provide detailed reports about flow patterns that weren't visible from above the waterline. Her aquatic perspective helped the humans optimize their barrier placements. The underwater currents show your main redirect channel is working perfectly, Chixara reported after returning from a scouting mission. But there's a secondary flow pattern developing near the lithoid dormitories that we should address. The lithoid students, whose rock-like bodies made them particularly vulnerable to water damage, were especially grateful for the human flood control efforts. Several of them volunteered to serve as living anchors for the larger barrier installations, using their natural weight and stability to hold redirect systems in place. Our species appreciates the practical effectiveness of human methodology. One of the lithoid seniors declared while positioning himself to anchor a critical barrier, "You have demonstrated that simple solutions can be superior to complex technologies." Even the arachnoid students began contributing their unique abilities to the project. Their natural web spinning capabilities proved perfect for reinforcing the blanket barriers, creating flexible but strong connection points that could adapt to changing water pressures. Nam Ji-hoon, the arachnoid head of engineering, was particularly impressed by how the humans had integrated multiple species' abilities into a cohesive solution. His own species was known for complex architectural projects, but they had never seen anything like this adaptive, multi-species engineering approach. "Your methodology represents a new paradigm in emergency response," Nam Ji-hoon observed while watching arachnoid students spin reinforcing webs between human-placed barriers. "You have created collaborative solutions that utilize each species' strengths without requiring technological dependencies." Haniel had taken charge of coordinating the expanded effort, organizing teams of mixed species to implement the barrier system throughout the residential section. Her leadership skills, developed during emergency response training on Earth, proved effective with alien species who were used to more hierarchical command structures. Team Alpha, extend the redirect system toward the central stairwell. Haniel directed a group that included humans, lithoids, and arachnoids. Team Beta, reinforce the barriers in the nebulae residential area where the air pressure changes are affecting flow patterns. Professor Crickstell had become fascinated by the human approach and was documenting their methods for future study. The renowned nebulae physicist had never seen engineering solutions develop so organically, with multiple species contributing their abilities to a constantly evolving system. This represents a fundamentally different approach to problem solving, Professor Crickstell noted while observing a team of humans and aliens adjusting barriers based on real-time feedback. Most galactic civilizations solve problems through careful analysis and precise implementation. Humans appear to solve problems through continuous adaptation and collaborative improvisation. Chun Woojin and Song Minji were leading efforts to expand the barrier system to the lower floors where the flooding had been most severe. They worked with hydrozoan students who could safely navigate the deeper water to place anchors and barriers in areas that were too dangerous for land-based species. The water level on the third floor has dropped by almost half a meter, Song Minji reported excitedly. Students who were trapped in their rooms are now able to evacuate safely. Kim Dong-yoon continued serving as a technical translator, helping alien students understand the scientific principles behind the human approach. His explanations were helping other species adapt their own abilities to support the flood control effort. The humans are applying systems thinking to environmental challenges, Dongyun explained to a group of confused silicarite students. Instead of trying to impose artificial control on natural forces, they're creating conditions that guide those forces toward desired outcomes. This concept was revolutionary for species like the silicarites, who were accustomed to solving problems through precise calculation and rigid implementation. The idea of working with natural forces rather than controlling them represented a completely different philosophy of engineering. Lim Soyoung was helping facilitate communication between species, groups that had never worked together before. Her linguistic abilities were crucial for coordinating efforts between aliens, whose languages and thought patterns were completely different. The avians want to help, but they can't work in the flooded areas, Soyoung translated. They're offering to serve as aerial coordinators, observing the overall flow patterns from above and reporting areas that need attention. The bird-like avians proved surprisingly useful in this role. Their aerial perspective allowed them to see water flow patterns that weren't visible to ground-based observers, helping teams prioritize their barrier placement efforts. As the collaborative effort expanded, Minho found himself serving as an unofficial technical coordinator. His understanding of flood dynamics, combined with his ability to work effectively with multiple alien species, made him a natural leader for the project. The main thing to remember, Minho explained to a mixed group of aliens and humans, is that we're not fighting the water. We're working with it. Every barrier we place should guide the water toward where we want it to go, not just block it from where we don't want it. This philosophy was slowly being adopted by alien students who had initially tried to solve the flooding through their species-specific technologies. They were learning that sometimes the most effective solutions came from cooperation and adaptation rather than advanced engineering. The results were becoming impossible to ignore. In areas where the human-led barrier system had been implemented, water levels were dropping significantly. Evacuation routes were becoming passable again. Students who had been trapped were able to reach safety. Your methodology has achieved flood level reductions of 40 to 60% in treated areas, Nam Ji-hoon announced to the assembled students. This exceeds the performance specifications of our most advanced flood control technologies. As the alien students saw the practical success of the human approach, more species began volunteering their unique abilities to support the project. The barrier system was becoming a true galactic collaboration, with each species contributing their strengths to a solution that none of them could have achieved alone. The transformation was remarkable to witness. In just 3 hours, the improvised flood control system had changed the entire residential section from a disaster zone into a manageable situation. Water that had been rushing chaotically through hallways was now flowing in controlled streams toward drainage areas where the building systems could handle it. Minho stood in the main corridor, watching the results of their collaborative effort. The water level had dropped from chest-deep to ankle-deep in most areas. More importantly, the flow patterns had been completely redirected away from critical residential areas and toward sections of the building where the drainage infrastructure was still functional. I have never observed environmental manipulation of this efficiency, Vextai commented, his crystalline body now glowing with healthy rainbow patterns as the humidity returned to manageable levels. Your species has demonstrated capabilities that our scientific databases did not predict. The silicarite student was examining one of their blanket barriers with obvious fascination. The simple textile, weighted down with furniture and anchored by his own crystal formations, had successfully redirected thousands of liters of water away from vulnerable areas. Thum had regained his normal density and was floating excitedly around the barrier installations. His gaseous form shimmered with what appeared to be joy as he observed the atmospheric improvements throughout the residential section. Pressure stabilization achieved. Humidity levels optimal. Air circulation restored to normal parameters. Thum announced. Human methodology has created environmental conditions superior to original baseline measurements. Chixara emerged from the water wearing what could only be described as an expression of amazement on her aquatic features. She had been swimming through the controlled flow channels, observing how effectively the barrier system was managing the water distribution. The underwater flow patterns are perfectly regulated, Chixara reported. The water is moving at optimal speeds toward drainage collection points. There is no turbulence, no dangerous pressure buildup, no electrical hazard zones. This is superior to our most advanced aquatic engineering projects. Nam Ji-hoon arrived with the official emergency response team just as the system was demonstrating its greatest success. The tall arachnoid engineer stood in the hallway, his mandibles clicking rapidly as he processed what he was seeing. "This is unprecedented," Nam Ji-hoon declared. "Our computer models predicted that flood conditions of this severity would require at least 12 hours to control using standard emergency protocols. Your improvised system has achieved superior results in less than 4 hours." Professor Crickstell was documenting everything with scientific enthusiasm. The renowned nebulae physicist had never encountered engineering solutions that developed so organically and effectively. His gaseous form sparkled with excitement as he observed the multi-species collaboration. "The most remarkable aspect is not just the technical effectiveness," Professor Crickstell noted, "but the collaborative methodology. You have created solutions that utilize the unique capabilities of multiple species working in coordination rather than competition." The emergency response team included sophisticated equipment designed for flood control, but much of it remained unused. The human-led barrier system was managing the situation more effectively than the high-tech alternatives that required stable power connections and complex setup procedures. "Our standard flood control protocols assume availability of full infrastructure support," admitted Dr. Zinakari, the station's chief emergency coordinator. "Your approach works independently of technological infrastructure. This represents a significant advancement in emergency response methodology." Students from throughout the residential section were now able to evacuate safely through corridors that had been impassable just hours earlier. The lithoid students, whose rock-like bodies had been seriously threatened by prolonged water exposure, were particularly grateful for the rapid improvement in conditions. "Human problem-solving demonstrates practical wisdom that our civilizations have overlooked," declared Morthok, one of the senior lithoid students. "We focused on developing advanced technologies while humans developed adaptive capabilities." The avian students, who had been serving as aerial observers, reported that the flood control system was working effectively throughout multiple floors of the building. Their bird's-eye view confirmed that the water redirection was functioning as intended across the entire residential section. "Flow patterns from aerial perspective show optimal distribution," chirped Keshwing, the avian team coordinator. "Water levels reduced by 60 to 70% in all treated areas, evacuation routes fully accessible." Even species that hadn't been directly involved in the barrier construction were impressed by the results. A delegation of crystalline collective representatives had arrived to observe the human methodology, expressing interest in studying these adaptive problem-solving techniques. "Your species has developed environmental manipulation capabilities that complement our technological approaches," stated Shardlight, speaking for the crystalline collective. "This represents valuable knowledge for interspecies collaboration projects." Haniel was coordinating the final phases of the evacuation, working with teams that now included representatives from every species in the residential section. The multi-species cooperation that had developed during the emergency was continuing as students worked together to ensure everyone's safety. "All residential areas now accessible for evacuation," O'Haniel announced. "Water levels stable and continuing to decrease." The barrier system is maintaining effective flow control without requiring constant adjustment. Kim Dong-yoon was explaining the scientific principles to groups of fascinated alien students who wanted to understand how such simple materials could achieve such sophisticated results. His technical explanations were helping other species appreciate the elegance of the human approach. The key insight is that complex problems don't always require complex solutions, Dong-Yoon explained to a mixed group of students. Sometimes the most effective approach is to work with natural forces rather than trying to override them with technology. Ling Soyoung was facilitating discussions between species groups about what they had learned from the collaboration. Many aliens were expressing interest in studying human problem-solving methods and incorporating adaptive techniques into their own emergency response protocols. The Nebulae students are asking if humans would be willing to teach collaborative engineering courses, Soyeon translated. The Silicarites want to include adaptive methodology in their crystalline architecture curriculum. As the immediate crisis passed, Minho found himself surrounded by alien students asking questions about human engineering philosophy. They wanted to understand how his species had developed such effective improvisation and collaboration skills. On Earth, we face natural disasters regularly, Minho explained. Typhoons, earthquakes, floods, storms. We learn to work with whatever materials we have available because we can't always rely on advanced technology to save us. This explanation resonated with the alien students, many of whom came from worlds where environmental challenges had been eliminated through technological control. They were beginning to understand that humanity's experience with unpredictable natural forces had developed valuable adaptive capabilities. Your species has maintained practical problem-solving skills that our civilizations have forgotten, observed Vextai. We became so focused on technological perfection that we lost the ability to improvise effective solutions. The success of the flood control system was becoming impossible to ignore. Water levels throughout the residential section had stabilized at manageable levels. Students were evacuating safely through previously blocked corridors. The collaborative effort had transformed a disaster into a controlled situation that could be managed until the storm passed and normal systems were restored. 3 days after the storm had passed and the residential section had been completely restored to normal operations, Minho found himself standing in the Academy's main lecture hall facing an audience of over 300 alien students and faculty members. The invitation to present his flood control methodology had come from the engineering department itself, specifically from Nam Ji-hoon and Professor Crickstell. I never expected to be giving a lecture here, Minho admitted to Yuna as they waited backstage. When I applied to the academy, I thought I'd be learning from alien professors, not teaching them. Yuna smiled. Sometimes the best teaching happens when nobody plans it. The lecture hall was filled with representatives from every major species in the galactic community. Silicarite engineers sat next to nebulae physicists, arachnoid architects, shared seating areas with hydrozoan environmental specialists. Even species that rarely left their home systems had sent observers to learn about human adaptive engineering. Director Yoon Sang-woo, the human head of the exchange program, introduced Minho to the audience. 3 days ago, our newest human student demonstrated problem-solving capabilities that saved lives and challenged our understanding of effective engineering. Today, Lee Minho will share the principles behind what many are calling the most significant advancement in emergency response methodology in recent galactic history. As Minho stepped up to the speaking platform, he felt the weight of hundreds of alien eyes studying him with intense curiosity. These were some of the most advanced beings in the galaxy, representatives of civilizations that had been building sophisticated technologies for millions of years, and they wanted to learn from a 20-year-old human who had used blankets and furniture to solve a flood. I want to start by saying that what we did during the flood wasn't particularly advanced, Minho began. Back on Earth, this kind of improvised flood control is basic emergency response. Every coastal community knows these techniques. This statement caused a stir among the alien audience. Professor Crickstell's gaseous form shimmered with excitement. Several Silicarite engineers began glowing with patterns that indicated intense interest. The key principle, Minho continued, is that we don't try to fight natural forces. We work with them. Water always wants to flow downhill and follow the path of least resistance. Our job is to give it a better path to follow. He gestured to a holographic display that showed the residential section during the flood. The chaotic water patterns from the beginning of the crisis were clearly visible, followed by the organized flow channels that had developed after the barrier system was implemented. We didn't stop the flooding, we controlled it, we guided it. We made it work for us instead of against us. Vextai raised a crystalline appendage to ask a question. Human Minho, your methodology appears to prioritize adaptation over calculation. How do you determine optimal barrier placement without detailed hydraulic modeling? We observe and adjust, Minho replied. We place a barrier, watch how the water responds, then modify our approach based on what we see. It's an iterative process. This answer seemed to puzzle many of the alien engineers. Their species typically solve problems through comprehensive analysis followed by precise implementation. The idea of building solutions through trial and adjustment was foreign to their engineering philosophies. Dr. Theckelur, a senior arachnoid professor, asked the next question. Your approach requires real-time decision-making without complete information. How do you manage the risk of suboptimal solutions? Sometimes a suboptimal solution that works immediately is better than an optimal solution that takes too long to implement, Minho answered. During an emergency, speed and adaptability are more important than perfection. The audience erupted in discussion. Multiple species began debating this concept in their native languages. The idea that imperfect solutions could be superior to perfect ones challenged fundamental assumptions about engineering and problem-solving. Professor Crickstel floated forward to address the audience. I have been studying Human Minho's methodology for the past 3 days. The most remarkable aspect is not just the technical effectiveness, but the collaborative framework that emerged. Multiple species contributed their unique capabilities to a solution that none could have achieved alone. Namji-Hun clicked his mandibles in agreement. The human approach created a new paradigm for interspecies cooperation. Instead of each species pursuing separate solutions, they were integrated into a unified strategy that utilized everyone's strengths. A lithoid professor named Granity Heart asked about the philosophical implications. Human Minho, your species, appears to view natural forces as partners rather than obstacles. How did this perspective develop? Minho thought for a moment before answering. On Earth, we can't control nature, so we learn to work with it. Typhoons, earthquakes, floods, they're going to happen whether we want them to or not. Our survival depends on adapting to them rather than trying to prevent them. This explanation resonated particularly with the nebulae representatives, whose gaseous nature made them naturally inclined to flow with atmospheric forces rather than fight against them. Several nebulae professors began expressing strong interest. In studying human adaptive methodologies, Chixara asked about the practical applications. Could human adaptive engineering be applied to other emergency scenarios? Absolutely, Minho replied. The same principles work for any situation where you need to solve problems quickly with limited resources. The key is to observe what's actually happening, work with the forces involved, and adapt your approach based on results. The presentation continued for over 2 hours, with alien professors and students asking detailed questions about human problem-solving techniques. Many expressed interest in incorporating adaptive methodologies into their own curricula and research programs. Dr. Zinakari announced that the Academy was establishing a new department of adaptive engineering with human consultation to study and teach these collaborative problem-solving techniques. The flood response demonstrated capabilities that complement our existing technological approaches. We believe this represents a valuable addition to galactic engineering knowledge. After the presentation, Minho was approached by dozens of alien students and professors who wanted to discuss collaboration opportunities. Vextai was particularly enthusiastic about exploring how crystalline engineering could be enhanced through adaptive techniques. I have requested approval to write my senior thesis on human silicarite collaborative methodology, Vextai announced. Your approach has shown me new possibilities for responsive crystalline architecture. Thum expressed similar interest. Nebulae atmospheric engineering could benefit greatly. from human adaptive principles. Would you be willing to collaborate on research projects? Even species that hadn't been directly involved in the flood response were expressing interest in learning human techniques. A delegation from the Quantum Collective requested permission to study human decision-making processes under uncertainty. Haniel approached Minho as the crowd began to disperse. I've been talking to the other human students. We're thinking about starting an interspecies engineering club where aliens and humans can work together on practical projects. The idea appealed to Minho immediately. That sounds perfect. We could use real problem-solving exercises to teach adaptive techniques while learning about alien technologies. As they left the lecture hall, Yuna commented on the transformation that had occurred. 3 days ago, the aliens saw us as primitive newcomers to the galactic community. Now they're asking us to teach them. Minho nodded, but he was careful to maintain perspective. We're not better than them. We're just different. They have incredible technologies and scientific knowledge. We have adaptive skills and collaborative experience. Together we can solve problems that none of us could handle alone. That evening, the Academy announced the formation of the first intraspecies emergency response teams, combining alien technologies with human adaptive methodologies. The flood had demonstrated that the most effective solutions often came from cooperation rather than competition between different approaches to problem solving. 6 months after the flood, the changes at Kepler Station Academy were visible everywhere. The most obvious difference was the new emergency response protocol posted in every residential section. Instead of relying solely on high-tech automated systems, the protocols now included sections on adaptive resource utilization and multi-species collaborative response. Minho stood in the Academy's new adaptive engineering laboratory, watching a mixed group of human and alien students work together on a practical exercise. Today's challenge was designing a temporary shelter system using only materials found in a standard dormitory room. The solutions being developed were remarkable combinations of alien technology and human improvisation. Your crystalline framework is excellent, Yuna told her silicarite partner while adjusting a blanket covering on their shelter prototype. But if we add this textile layer, we can make it weatherproof and insulated at the same time. Vextai's body glowed with satisfaction as he observed how the simple human addition improved his precise crystal architecture. The textile integration creates thermal regulation that my calculations did not predict. Human materials science appears to operate on different principles than silicarite engineering. At another workstation, Taeyong was collaborating with Thum on an atmospheric processing shelter. The gas being was using his natural abilities to create air circulation patterns while Taeyong designed ventilation channels using repurposed furniture and bedding. The key is to work with your natural airflow instead of trying to control it completely, Taeyong explained as he positioned a blanket baffle to guide Thum's atmospheric currents. Let the air go where it wants to go, but give it a path that serves our purposes. Kim Dong-yoon was serving as technical coordinator for a team that included Chiksara and several lithoid students. They were designing a shelter that could function in both dry and flooded conditions, combining hydrozoan water management with lithoid structural stability and human adaptive techniques. The brilliant part about this design, Dong-yoon explained to Professor Krickstel, who was observing the exercise, is that it doesn't try to be perfect for any single environment. Instead, it's adaptable enough to function effectively in multiple conditions. The nebulae professor's gaseous form sparkled with intellectual excitement. This represents a fundamental shift in engineering philosophy. Instead of optimizing for specific conditions, you optimize for adaptability itself. Haniel was leading a workshop for alien professors who wanted to understand human teaching methodologies. The Academy had discovered that human educational techniques were as valuable as human engineering techniques, particularly for teaching adaptive problem solving. The important thing is to let them make mistakes and learn from them. Haniel explained to Dr. Thekaler and several other alien educators. We don't tell them the right answer immediately. we guide them toward discovering it themselves. This approach was revolutionary for many alien educational systems, which typically focused on transmitting correct information rather than developing problem-solving capabilities. The results, however, were undeniable. Students trained in human-style adaptive learning were proving more effective at handling unexpected challenges. Lim Soyang was facilitating communication between student teams that included species whose thought patterns were completely different. Her linguistic skills had evolved to include not just language translation, but conceptual translation between different ways of understanding problems. The arachnoids are thinking about this structurally, Soyang explained to a mixed team. The nebulae are thinking about it atmospherically. The humans are thinking about it adaptively. We need to find a solution that incorporates all three perspectives. The interspecies engineering club that had started as Minho's idea had grown into one of the Academy's most popular programs. Every week, teams of aliens and humans worked together on practical challenges that required both advanced technology and adaptive improvisation. Nam Ji-hoon had become one of the strongest advocates for the human approach. The arachnoid head of engineering had integrated adaptive methodologies into the Academy's core curriculum and was collaborating with human educators to develop new teaching techniques. The humans have taught us that advanced technology is most effective when combined with adaptive thinking, Nam Ji-hoon announced to the monthly faculty meeting. Our students are now graduating with capabilities that exceed the performance of previous generations. The changes weren't limited to emergency response and engineering. Human collaborative techniques were being applied throughout the Academy's programs. Diplomatic studies now included courses on multi-species problem-solving. Scientific research programs emphasized adaptive methodologies, alongside traditional analytical approaches. Minho found himself in the unexpected position of serving as an informal consultant to alien professors who wanted to incorporate human techniques into their courses. His understanding of both human adaptive thinking and alien technological capabilities made him valuable as a cultural bridge. The goal isn't to make aliens think like humans, Minho explained to a group of faculty members. It's to help everyone understand that there are multiple effective approaches to solving problems. Sometimes the best solution combines several different ways of thinking. Director Yoon Sang-woo had documented the Academy's transformation in a report that was being studied throughout the galactic educational community. Other institutions were requesting human consultants to help them develop similar adaptive programs. The Kepler station model is being replicated at 17 other galactic academies, Director Yoon announced proudly. Human adaptive engineering and collaborative methodologies are becoming standard components of advanced education. The most significant change, however, was in the relationships between species. Before the flood, different alien species had tended to work separately, each relying on their own advanced capabilities. The collaborative response to the emergency had demonstrated the value of combining different approaches instead of competing between them. Vestan had become Minho's closest friend at the Academy, despite their completely different biological and cultural backgrounds. The Silicarites' scientific precision complemented Minho's adaptive intuition, and their joint projects consistently produced innovative solutions. Your species has taught me that precision and adaptability are not opposites, Vestan reflected as they worked together on a new shelter design. They are complementary approaches that become more powerful when combined. Thum had learned to appreciate the value of working with chaotic forces rather than trying to control them completely. His atmospheric engineering projects now incorporated human-style adaptive techniques, resulting in systems that were more resilient and flexible. Humans understand that chaos contains opportunities, not just problems, Thum observed. This perspective has improved my atmospheric manipulation significantly. Even Shiksara had adopted human collaborative techniques in her aquatic engineering work. Her senior project combined hydrozoan water mastery with human adaptive principles to create Revolutionary new approaches to environmental management? The most valuable lesson from the flood response was not about engineering, Chixara noted. It was about cooperation. When different species work together instead of separately, we achieve results that none of us could accomplish alone. As Minho prepared for his final semester at the academy, he reflected on how much had changed since that stormy night when the residential section had flooded. He had arrived at Kepler Station expecting to learn from advanced alien civilizations. Instead, he had discovered that humanity had valuable knowledge to contribute to the galactic community. The new storm warning system activated, indicating another severe weather exercise was beginning. But this time, both alien technology and human adaptive techniques were ready. The residential section now had both advanced automated flood control systems and stockpiles of blankets, rope, and furniture positioned for emergency use. More importantly, the students knew how to work together. Aliens and humans had learned to combine their different capabilities into collaborative solutions that were more effective than any single approach. As the first drops of rain began hitting the dome above, Minho smiled. The academy was ready for whatever challenges the storm might bring, because they had learned the most important lesson of all. The best solutions often come from working together, using whatever resources are available, and adapting to whatever nature throws at you.